Alright, pause your video. Try this problem before we go over it. Alright, well, when we're adding vectors, it's helpful to break them down into their x, y, and z components, because then all you have to do is add each component separately. So just to recap, a unit vector is a vector that has a magnitude of 1 and points in the positive directions of x, y, or z. And in this example, we're rewriting vector A, vector A's x component, and labeling that I hat, and vector A's y component, and labeling that j hat. Now, the AX and the AY, these parts here, they're known as the scalar components, or simply the components of the unit vectors. Alright, let's take a look at our problem. Alright, so beetle 1 and beetle 2. We have two beetles making 2 runs each. I'm going to zoom out here, it gets a little more room. So let's use vector A to label beetle 1. And we'll say A1 is going to be the beetle 1's first run, and then A2 will be beetle 1's second run. So if we can draw this out, it might look something like this. Right, the first one, it says it goes 0.5 meters directly east, so that's just in the positive x direction, and then it goes 0.8 meters on a 30-degree angle, so something like this, and this is not drawn to scale. So there's 30 degrees, and that is 0.80 meters. Alright, so let's write that into each of those runs in the unit vector notation. Run 1 only has one component, so that is going to be 0.50 meters I hat, sorry. And then the second run, we're going to need to use some trig because it's going in 2 dimensions. To get the I component, we're going to multiply 0.80 meters by the cosine of the angle, which is 30. Alright, and we're going to get the j component by getting 0.80 meters times the sine of 30. Alright, so we're going to plug those in our calculators. All we have to do is we're going to add these two vectors. Alright, so cosine 30 times 0.8, and we're going to add that to the first run's I component, which is 0.5, so it's plus 0.5, and when we add beetle 1's runs, first and second run, it's the sum will be 1.19 meters I hat. Right, let me write that down. And the j component is simply going to be sine 30 degrees, which is 0.5, and times that by 0.8. And we don't need to add that because the first one didn't have a y component. Alright. So let me just write all this down. We're going to get 1.19 meters I hat plus 0.40 meters j hat. Alright, let me clear this out. Alright, now let's work on Beetle 2's runs. And I'll do this in a different color. Alright, it says Beetle 2 makes 2 runs. The first run is 1.6 meters, 40 degrees east of due north. So something like that. This is going to be 40 degrees, which means this here is going to be 50 degrees. Let me rewrite that 5 better. And that's 1.6 meters. That beetle is running. All right, so that is this is a 4. All right, so it's asking us what is the vector of the second run. In other words, what's the magnitude and the direction of its second run to end up at the same point where Beetle 1 ends up. All right, so let's do the same thing with Beetle 2. We're going to rewrite both of its runs. Beetle 2, run 1 called B1 vector. And what did it say? 1 point. We're going to need to use our trig functions again. So 1.6 meters. I want to use the 50 degrees, but you can use the 40 degree triangle if you want. But I'll use cosine 50. And then the j component will be 1.6 meters sine 50. Alright, so let me plug that in my calculator, and you should get 1.03 meters I hat plus 1.23 meters j hat. Alright, so we have all the runs except for Beetle 2's second run, which is what it's asking us to solve for. So if you can picture Beetle 1's runs have to equal both Beetle 2's runs. So just write that, right what I just said. Vector A1 plus vector A2 I'm going to add up to vector B1 plus vector B2. We have all of these except for B2. And so what we can do is, to solve for that, we're just going to move B1 to the other side, and we can get vector B2 by adding A1 plus A2 minus B1. Well, we already added A1 and A2, so that's right here. So if we take that and subtract B1, we'll get B2's I component, which is 0.16 meters I hat. And if you take 0.40 and subtract 1.23, I get plus negative 83 meters j hat. Alright, so we have there's our vector B2, Beetle 2's second run. And to get the magnitude, we're going to use the Pythagorean theorem. And so that's going to look like 0.16 squared. We'll add that to 0.83 squared and get the square root of that. And so our magnitude for vector B2, the Beetle2's second run, is 0.845. Actually, if you didn't round earlier, you may have gotten 0.84. So let's see. Answer to A is 0.84 meters is the magnitude. By the way, we should have checked our answer with the diagram we drew earlier. So is it going slightly in the positive x direction, and is it going in the negative y direction? I know this is not to scale, but that's kind of in line with our drawing. Right, so now we need to find the angle of this second run, the direction. Right, and to do that, we can, that's going to be tangent of the angle that we're looking for is going to be opposite over adjacent, and so that's going to be negative 0.83 over 0.16. We're going to solve for theta, get the inverse tangent of that. And when you plug that in your calculator, you should get negative 79 degrees. So this angle up here is negative, or this angle down here is going to be 79 degrees south of east. Or you could say 11 degrees east of south.